Assalamualaikum viewers, Nigat Gul. I welcome you in my YouTube TV channel. Today my topic is reliability. First of all, what is reliability? What is reliability? Simply consistency of the scores. Consistency of the scores. Consistency of the scores. When we get we get the same results and consequences of the one test when we apply again and again on different participants in different times with suited time interval. This is called reliability. When we get the consistent results or consequences again and again by applying the same test is called reliability. Major two types of reliability. One is internal reliability, external reliability. Internal reliability is a type of reliability which deals with the measurement of inter-items correlation and check the factors this will general reliability. There is different types of the types of reliability: inter-rater or inter-observer reliability, test-retest reliability, parallel farm reliability. These three types of reliability comes under the external reliability: inter-rater, inter-observer reliability, test-retest reliability, inter-rater reliability, test-retest reliability, parallel farm reliability. The types of external reliability and internal reliability: split half reliability, crown back alpha reliability, inter-item correlation, and total inter-item or average inter-item correlation. Now we explain further more inter-item reliability, inter-observer, object or phenomena. One test of anxiety. and observe or rate by two observer, one observer and two observer, and both observer give the same observation and same rating for the one test. Is This test have a inter-rater or inter-observer reliability. If two observers give different and varied observation and rating of the one test, is there is no inter-rater and inter-observer reliability. When two observers differently observe the one test or object or phenomena, this have no observer inter-rater reliability. Whenever you use human as a part of your measurement procedure, you have to worry about whether the results you get are reliable or consistent. People are not used for their inconsistency. We are easily distractible. We get tired of doing repetitive talks. We daydream. We misinterpret. So, how do we determine whether two observers are being consistent in their observation? You probably should establish inter-rater reliability outside of the context of the measurement in your study. After all, if you use data from your study to establish reliability and you find that reliability is lower, you are kind of stuck. Probably it is supposed to do this as a side study, pilot study, and if your study goes on go for a long time, you may want to re-establish inter-rater reliability from time to time. I assure that your rater are not changing. There are two major ways to actually estimate inter-rater reliability. If your measurement consists of categories, the raters are checking off which category each observation fall in. You can calculate the percentage of average between inter-rater. For instance, let's say you had 100 observations that were being rated by two raters. For each observation, the rater could check one of three categories, and you imagine that on 86 of the 100 observations, the rater checked the same category. This is case the percentage of agreement would be 86%. Okay, it's screwed bad, but it does go an idea of how much agreement exists, and it works no matter how many categories are used for each observation. The another way to estimate inter-rater reliability is appropriate when measure is a continuous one. There all you need to do is calculate correlation between the rating of two observers. For instance, they might be rating the overall level of activity in a classroom on a 1 to 7 scale, Likert scale. You could have them give their rating at regular time intervals. For example, each 30 seconds. The correlation between these ratings would give you an estimate of reliability or consistency between the rater. You might think of this type of reliability as calibrating the observer. There are other things you could do to encourage reliability between observers. Even you don't estimate it. For instance, I used to work in a psychiatric unit where every morning our nurse had to do a 10 items rating of each patient on the unit. Of course, we couldn't count on the same nurse being present every day, so we had to find a way to assure that any of the nurses would give comparable rating. The way we did it was to hold weekly Calibration meetings where we would have all of the nurses rating for several patients patients and discuss why they choose the specific values they did. If there were disagreement, the nurses would discuss them and attempt to come up with rules for deciding when they would give a 3 or a 4 for a rating on a specific item. Although this was not an estimate of reliability, it probably went a long way towards improving the reliability between raters. Test retest reliability. One test we measure one time and again second time, and we apply the same test on different occasions on different participant on the same participant again and again, and we get the consistent and same results. This is called test retest reliability. If tests give consistent results in different times, apply first time and second time on different participant or same, and we get the same consequences is test. This test have test and retest reliability. Parallel form reliability. Parallel form, we have parallel two forms, form A and form B. Both of the forms have items which are measuring the same subject matter and study phenomena. For example, anxiety two forms, A form and B form, and one time apply A and second time apply B again and again on different participant or same participant, and we get the consistent results. This have the parallel form reliability. We can develop two forms of the one test, or we can use as a form B or parallel form any other existence results which is before developed by any one person for anxiety and similar to my construct. So I can make the comparison. I can use as a form B. Form A is my develop construct test and form B is a similar test, and I can develop two pools of the items and form A and B, then can apply differently on different times A and B form on the same participant and different participants, and if get the same consistent result, then this test have a parallel form reliability, otherwise not. Internal consistency reliability estimate. We use our single measurement instrument administered to a group of people. A group of people on one occasion to estimate reliability. In effect, we judge the reliability of my instrument by estimating how well the items that reflect the similar construct yield similar results. We are looking at how consistent the results are of for different items for the same construct within the measure. There are wide variety of internal consistency measure that can be used. Average inter-item correlation. The average inter-item correlations use all of the items on our instrument that are designed to measure the same construct. We first compute the correlation between each pair of items as illustrated in the figure. For example, if we have 6 items, we have 6 different items. 6 items, we have 15 different item pairings. Correlation. The average inter-item correlation is simply the average or mean of all these Correlations in the example, we find an average inter-item correlation of 0.90 with the individual correlation ranging from 0.84 to 0.98. An average inter-item correlation 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. One item 2, 3, 4, 5 and 6. And high, range is between 0.84 to 95. And average inter-item is 0.90. Average item total correlation. This approach also used inter-item correlation. In addition, we compute a total score for the 6 items, and we use that as a 7 variable in the analysis. The figure shows the 6 items to total correlation at the bottom of the correlation matrix. They range from 0.8 to 0.88 in this sample analysis, with the average of these at 0.84. Now, average item total correlation with 6 pairs correlation, and average item total correlation 0.84, and range you are observing here 0.82 to 0.88. Split half reliability. In split half reliability, we randomly divide all items that purport to mirror the same construct into two tests. We administer the entire instrument to a sample of people and calculate the total score. For each randomly divided half, the split half reliability estimate as shown in the figure is simply the correlation between these two total scores. In the example, it is 0.87. There are 1, 2, 3, 4, 5 and 6 are total item, and we split in two halves. One half 1, 3 and 4. Second half 2, 5 and 6. And we differently apply two halves of the test on same participants on different participants with the suited time interval again and again, and we get consistent and similar results. Then there is existence of the split half reliability. Otherwise, if we get varied and different results, consequences by applying of the two halves of the test in different time, is there is no split half reliability. If there is no split half reliability, automatically there is no internal consistency and internal reliability of the test. Now, Cronbach alpha is also one type of the internal consistency. Cronbach, imagine that we compute one split half reliability, then randomly divide items into another set of split halves and recompute, and keep doing this until we have compute all possible split half estimates of reliability. Cronbach alpha is mathematically equivalent to the average of all possible split half estimates. Although that's not how we compute it, notice that when I saw we compute all possible split half estimates, I don't mean that each time we go and measure a new sample that would take forever. Instead, we calculate all split half estimates from the same sample. because we measure all of our sample on each of the 6 items, and all we have to do is have the computer analysis to do the random subsets of items and compute the resulting correlations. The figures show several several of the split half estimate for our 6 item sample and list them as such. With the subscript, just keep in mind that Cronbach alpha is equivalent to the average of all possible split half correlation. Split half correlation, two halves, estimated correlation of the two halves. Now there is 8.8787 and alpha is 0.85. As such, 1 half, 2, 3, 4, 5 and now alpha is point. This is the one item. As such, a list of item sh1 sh2 as list of the item 3 4 and 5. There is different items 1 1 2 3 4 5 6 7 8 9 pairs of 3 items, 3 pairs, and s1 2 3 sh4 5 sh5, and there are different alphas, different reliabilities, and estimated reliability. Average of all splits average is 0.85. We can compute it by statistical method as well through SPSS, and this is high alpha, so there is existence of the internal consistency of the test. Hopefully you maybe learn well types of the reliability, and if you you like, then like my video and share with your friends, and like and subscribe a YouTube TV channel. Thank you very much.